Hello viewers, question 5. So we have a system of forces and we need to find the equilibrant for the system. So as with the last video, we'll find the resultant and then reverse the direction at the end. So we've got three forces here. We've got a 1234 Newton force pointing upwards. Let's convert that into kilonewtons so we've got consistent units. So pointing upwards, we have a 1.234 kilonewton force, which has a horizontal component of 0 because it is a vertical force, and the vertical component is 1.234, and that is going to be positive because it's an upwards force. We then have below the horizontal on the right we have a 1 kilonewton force at 45 degrees. So the horizontal component is going to be, we're dealing with this right triangle. The horizontal component is the adjacent side and its hypotenuse is 1. So it's going to be 1 times, since it's the adjacent side, its cosine of 45, pointing to the right makes it positive. And the vertical side is going to be the opposite, so that's going to be the sine side of 45, hypotenuse is 1, and this is pointing downwards, which makes it negative. And then below the horizontal on the left, at a 70 degree below the horizontal angle, we've got another 1 kilonewton force. So the horizontal component is going to be, we've got the horizontal component is going to be the adjacent side. So we're dealing with cosine of 70 degrees, and the hypotenuse or the magnitude of the force is 1. This is pointing to the left, which makes it negative, and the vertical component, which is going to be this side, is going to be the opposite side, so that sine angle is 70 degrees, and the length is 1, pointing downwards makes it negative. Okay, so let's work out our totals. So the horizontal component turns out to be positive 0.365, and the vertical component turns out to be negative 0.413. So let's work out the rough direction. Let's remind ourselves that this is of the resultant. So the horizontal is positive, which means it's pointing to the right, and the vertical is downwards because it's negative, so it's going to be going roughly in that direction. Now we need to find what the length is and what the angle is. So that's theta, and let's put in what the horizontal component is, which is 0.365, and the vertical component of that resultant is 0.413. So let's work out its length, which we'll get by Pythagoras. That's going to be square root of 0.365, that's squared, plus 0.413, that's squared, and if we calculate that we get 0.551 kilonewtons, or 551 newtons. Okay, so we've got the magnitude. Now we need to work out our angle. So we're using the data that we found from the table, the totals of the two columns. So we've got here, this is the opposite side, that's the adjacent side. So we're using tan, finding an angle, which means it's inverse tan of opposite is 0.413, and the adjacent is 0.365. And if we calculate that, we find that we get a 48.5 degree angle. Now, because the opposite is larger than the adjacent, we should be getting an angle that is larger than 45 degrees, and we are. If you had a situation where the adjacent is greater than the opposite, you will get an angle less than 45 degrees. Our angle here is 48.5, so it's the side of 45 that we are expecting. Let's draw in our resultant. So our resultant is, it's a 551 Newton force pointing downwards to the right at an angle of 48.5 degrees below the horizontal. Equilibrant is therefore going to be in the opposite direction. So it's going to be a 551 Newton force. It is going to be at an angle 48.5 degrees. That angle is the same, but its arrow is pointing in the opposite direction, which means it's now going to the left and it's now above the horizontal. Okay, thanks for watching. Over and out.